Michael, did you want to add to this? Or a different
I
question?
was just going to say, I thought the loss tangent was tangent delta equals epsilon double prime over epsilon.
Tangent of delta equals?
Is there a copy of the book? I was wondering about that. Like, it uses tangent of delta, and I can't remember exactly how. So
You may be right.
Yeah, it's tangent of delta equals.
This should be tan inverse y by x, right? The slope. So, yeah, so epsilon, this is that. Does that make sense? Is that correct now?
Yeah, and that gives you delta.
That gives you delta, so that's delta. Right. Delta equal to tan inverse epsilon double prime by epsilon prime. But is that a loss tangent? No. The loss tangent is tan epsilon prime by epsilon. Right?
The loss tangent
Is tan delta. If that,
Yeah, loss tangent is tangent of delta.
okay, so hold on. Here's what you're trying to say, right? Loss tangent is tan delta, where delta is
tangent of delta equals epsilon double prime over epsilon.
right? Which means right? I stand corrected. So the reason why it's called that, I mean the loss tangent comes about is because of this guy. The slope of that complex primitivity. Other questions? We still have 10 minutes to kill, so if you guys want to bother your classmates with more questions that you might have, then it's an open class today. Any other general questions?
And so in that case, would you use skin depth for delta?
Skin depth delta is this guy.
Okay.
I think the delta here is different.
Okay, see that explains why, yeah, I had some issues, and so I just left actually the complex part of epsilon 0, because I got closer values. And I just put a note in my homework, I was like, I got something wrong, but that's exactly why. Yeah, I didn't have the right delta.
So again, thanks for bringing that up now, because notation, again, notation is important. Delta, skin depth is used mainly for, say, some sort of conductive material, hence the use of conductivity sigma, right? That gives you an idea of, let's say, let's say that you're designing a shield for your microwave oven. Sound interesting? How would you design a shield for your microwave oven in order to keep other Homo sapiens going around the oven safe from radiation?
Under what?
Right? That doesn't keep it inside, it just absorbs the whole thing. The way that microwave oven was actually invented was a guy in Raytheon walked past a really powerful radar with a chocolate bar in his pocket, and the chocolate bar melted, leading to the invention of the household microwave oven. Hence, it is important to think about shielding your microwave devices. So you must have noted that your microwave oven usually had knobs and stuff here. Has a small window. It's never glass. What is it?
Isn't it metal? Just mesh metal? It's like
It is a glass, but with a mesh. And the reason why that mesh is made so is because at 2.4 gigahertz, approximately 11 centimeter wavelength, they can't pass through a couple millimeter wide spaces. I mean, they'll get absorbed in the metal. That's why it forms a good Faraday cage. Okay. Now, that brings me back to the skin depth. So if you designed a any sort of waveguide or anything that you want to keep the field contained in it, then you would go for, sometimes you gold plate some things, like your strip lines. That helps to improve the conductivity a little bit and keep the material inert, because gold is kind of an inert metal. But if you don't calculate the skin depth, you might end up using a lot more gold, and your marketing, HR, CEO, whoever will not be happy, because gold costs money. So if you calculate the exact amount of skin depth that you need, the thickness that you need for all these expensive materials, you could save some money. So usually the rule is 5 delta is good enough, because again, skin depth comes from the fact that you need something to decay by a certain amount. So here, if you use 5 delta, e raised to minus 5 is 99.9% decay. So the fields don't make it through 5 delta. Anything more than that is just wastage. I mean, field strengths will not be sufficient enough to do anything beyond 5 delta. Some people also say 3 delta. 3 delta is about 90%, I think. Yeah. So that's important to know, that skin depth not the same as this guy, because this is conductors, that's dielectric. Any other questions? Who's going to win the game tomorrow?
Us?
I was just getting really cocky after the last game, but no, yeah. JJ and you freshman year, all over again.
I saw it like last
Anyone
year.
have any questions for the open class? Apart from the game. You do? Questions? Nick?
Well, all right. I'm looking at what I was looking at before, and it says, okay. I think the delta is, instead of like the two divided, it's like the product, because it pulls out from the full epsilon. I'll just write what it has up there. Okay, I'll just take out the diagram. Alright, so it has epsilon R, and it says,
One that I have is this big. I don't know.
Really?
I don't know why they gave me that one then.
Circles after this. Circles after this.
okay, so this is skin depth, right?
Mine is
That was skin
double
depth?
size. That's what I'm saying.
This was, you were showing skin depth, alright, so I just want that there. And, so this is what it shows, and so that's why I'm thinking, okay, if it's tangent inverse, then it's tangent inverse of the product. Right? Am I right there? Of the two epsilon parts. Is that right? So, so like epsilon prime times double prime, so that would be the tangent inverse?
No, because there was no epsilon prime to begin with on the imaginary part, so you would divide it.
Oh, okay, alright,
It
yeah.
is the same thing.
Okay, alright, yeah, I just wanted to clarify.
That's a good form to remember.
Okay, yeah.
That's why
3 minutes. Yeah.
No, off of the table. You said use epsilon R.
Yeah.
You were looking at the wrong columns, so the times 10, it goes, well, no.
I asked you, like, not on God.
You said use epsilon R. No, not epsilon R.
You know what?
Yes, it's just
I
not
kind of
like-
thought about that. I think it's,
Yeah. So I even pointed out
Surface
to you, I'm like, no,
resistivity,
I
this is
want
actually
this
surface
column.
resistivity.
And you said, okay, yes, that.
Did you all use the
Yeah,
same
that's one that we
expression?
used.
Yes, so
Yeah,
that's right, that's not
I didn't
epsilon
use
r, you
general
don't use
form,
epsilon r,
but
it's epsilon r times epsilon r.
we already made the assumption
Yeah.
that mu r is 1.
I didn't say use that column.
Yeah, you did.
This guy is
So you
also
can choose
resistivity. And
So
that's
it's all.
No, I said, okay.
No, the two epsilons in that column.
Oh,
what's the difference?
Epsilon r.
Yes, I know. Now I
Epsilon
said use
uses-
the one on the left. And you asked me to
I
select
actually
the one
want to
that goes up, and I just got mixed up in my
investigate that
head.
further. Like,
Okay,
So we used.
I mean, this is
no,
clearly
we
frequency.
said the wrong value, or
And
the
that's
wrong epsilon.
no. That's more of a bulk
So you
conductivity.
said
and
use
resistivity
epsilon r,
property.
you used
So-
the epsilon r times epsilon naught, which was in that column.
So actually,
So
it's
just use the right.
column that you're talking, oh my god, Jeff.
That doesn't change the fact that it was the right number.
Okay, Jesus Christ, you're right.
Oh. We started out a week ago.
I mean, if you look at this way, this is per second. So if you do dimensional analysis, this is Henry per meter. This is, what is it, Siemens per meter. No. Yeah, Siemens per meter. So Henry per meter, Siemens per meter gone. This is,
Henry's per seconds per second. To the half.
Should be ohms, don't you think? Because R over there is RS and over 2 pi 1 over 8 plus 1 over B. So R has to be ohms. R to base has to be ohms.
yeah, but there is another expression for it here which doesn't really do you any good. That's even better. So, so question here is what's the units for RS? Meter. This is per meter. This is
I put in
ohms.
per meter. I thought it
Ohm meter.
Ohm per meters,
Ohm meter.
or ohm.
R surface is ohms per
Ohm
meter.
meter.
Oh, yeah, it's ohm meters.
R surface?
No, that is in ohms per meter.
Yeah, it is.
So R has to be just ohms. Because we're dividing by A anyway, so that's going to give you per meter. So R sub S is in ohms, R is in ohms per meter.
Yes,
Yeah, that's
it's,
right.
R sub S is in ohms per square.
Yeah.
Ohms per what?
Per square.
Per square
Yeah.
meter.
Yes, square.
Ohms per square. Might actually be right. I've seen that.
R is
I've seen that notation.
Oh, they do have this block in like the page there.
Yeah, that's not a missing font.
Okay, yeah, oh my god. Can I see the book again?
Ohms per square. But I do want to see what it actually means in terms of bulk conductivity. Oh, sorry for exceeding the time. Thank